Hi, my name is Marko Keskinen. I'm university lecturer at Aalto University's Water and Development Research Group. And with this presentation I'm going to tell you about water and its linkages to energy and many other things. And from this first slide you can see links that provide you more information on the topics of this presentation. And the links include also a link directly to this very presentation. And through that link you can find more detailed information on diagrams and other things that I'm not going to go through during my presentation. Okay, so the aim of the presentation is first of all to look at water use and its availability, and then talk about a little bit how water links first of all to food and then also to energy production, and ultimately then provide also possible solutions on how to move forward. And the scale at which I'm going to provide my views is mainly global. Okay, let's move forward. Here you can see our globe, or Mother Earth, and its surface water. So fresh water, not including the marine seawater or the groundwater or the ice. This is from our research findings. And as you can see, the water is almost everywhere in this blue planet, although there are spots where, like Saharan desert in Africa, where there's little water available. But then when we start to look at the availability of renewable water resources, we note that the picture looks already very different. This is now grouped according to latitudes which run there, and you can see that especially around equator there is loads of water available. But when we look at where the people are actually being located, we note that they are mainly on northern side of equator, which means that then when we group together the renewable water resources and the population, we get the water resources per capita, per people, and that means that there is a radical differences in globe how water resources are being distributed. On top of that, we can, for example, look indicators like gross domestic product, which measures the economic production and development, which again looks quite different, and then Happy Planet Index that tries to measure the happiness or the well-being of people, again providing a bit differing trend. So the point here is that the water is being distributed quite unequally after all on globe, and that it doesn't correspond nor with the population or the economic growth. And another way to look at globe, of course, is based on countries. And this picture shows all the countries of the world, and the colors show the population under water shortage, meaning how much water available there is per person per year. And when there is a yellow, orange or red colors, it means that those countries are under moderate, high or extreme water shortage. And as you can see, again, the picture is quite different. There are especially countries in Asia and Africa, partly in Latin America, under water shortage. And when we look at how this has historically developed, so obviously this links very much to the global population growth. So back in 1960s we had around 3 million people, and the water shortage was not as acute problem. But already in 2000 we had doubled our global population, and both the countries and the amount of people under water shortage has grown really rapidly. And the current estimates with around 9 billion people, or up to 9 billion people by 2050, show that the water shortage will increase radically, both in terms of countries and the number of people included. Parallel to that, of course, in 1960, in 2000, in 2050, we had one planet and the resources we have there. The amount of water, for example, is fixed in that very one planet. And this is, of course, an equation that is not necessarily very sustainable, and we are already seeing worrying signs of that in terms of environmental degradation, worsening water quality, and of course the very important challenge of our humankind, the climate change. So the picture is quite clear that our world is seeing a water crisis, with increasing amount of people facing water shortage and environmental degradation. And then at the same time, the amount of natural resources in our one planet, including water resources, is fixed. So from here it's clear that something needs to be done, and that something must relate to the major water users here in globe. So let's first look at those water users. Agriculture is clearly the most dominant of all water users in globe. From the picture on left, you can see on those green colors mark the agricultural water use, both in terms of extraction, meaning water being withdrawn and returned to the system, or then by consumption, meaning the water is withdrawn and not returned back to the water ecosystem. And globally, agriculture consumes up to 90% of all water, whereas then the domestic use, including drinking water or industrial use, only accounts for around 5% both. Of course, there is a very different situations between the countries and regions of the world. On the right-hand side, we can see a globe grouped according to these same colors, with green marking agriculture, red industry, and blue now for domestic use. And when zooming in for agriculture, for example, we can note that especially in developing countries, or so-called global south, the agricultural water use is really intensive, whereas, for example, in Europe and North America, the water consumption is less remarkable. And then when looking at the trends, this figure coming from our own research, again we can see that the water consumption trends have been increasing over time, practically in all areas in the world, and the share of the irrigation water marked here with yellow is a very dominant in all areas. Interestingly, there are also some decreasing trends in some regions, so picture is not unified all over the globe. But overall, this water use data shows us clearly that the agriculture is something that we need to look at more carefully when we are talking about water management, water governance, and tackling the water crisis we are seeing. So the question is not really how to drink less water, but how to eat less water. And I'm not going to go too much into detail on this topic. It's a very interesting and complex topic. But just to note that it's not only about so-called blue water or the irrigation water, but it's also quite much to do with the rain-fed agriculture. So the green water, which means the water in the soil, not in the surface waters. Because up to 80% of the land area is actually under green water, and 60% of our crops come from rain-fed agriculture and not from irrigated agriculture. So while not going into detail, I ask you to look for more information on the concept of water footprint. That is actually a very handy concept to measure and understand the water use of different products, including food products. And another issue, of course, to take into account there is then the diets and how much calorie intakes and others we can produce with different kind of water and different kind of crops. And this is also an area where there's loads of research, and one example of our own research is shown in the maps there. So this is so clear that water and food is a very crucial, important topic when talking about water management. But now moving then to water and energy. So while we could talk about thermal power plants and others that also have impacts on water system and are dependent on water, I here focus on renewable energy that actually very clearly increases pressure on water resources management. Johannesburg Summit on Sustainable Development back in 2002 very clearly demonstrated the international push to increase the share of renewable energy sources. This was mainly due to combat against climate change, to increase the climate change mitigation efforts. And as a result from this process, renewables are already a remarkable energy source, with 30% of global primary energy supply and over 22% of global electricity coming from renewable sources, and this share is thus increasing. But what makes it interesting is that where that actually renewables are coming from. So when we look at the world total primary energy supply in this slide, we can see that it's still very much dominated by oil, coal and natural gas. But then come biofuel and waste, nuclear and hydropower. And others, including solar and wind, are still quite marginal. And then when moving to the actual renewable energy production types and looking, for example, electricity generation, we know that majority of electricity generation with renewable energies is done actually by hydropower, followed by bioenergy and then wind power. And from water perspective, of course, interesting is that both bioenergy and hydropower are very water intensive. In this way, I would actually argue that when we talk about renewable energy, we actually mainly talk about water energy sources that are dependent on water. And for hydropower, particularly remarkable being for electricity production, and bioenergy for primary energy supply. So I will now talk a bit more about these two types of energy production and their linkages to water. So first, moving to bioenergy. So there are different ways to produce biomass from different crops, from waste, from forest products and so forth, but major part of that production is related to agriculture. And of course, policies have a major role in promoting bioenergy. So renewable energy is in a way it's something to be promoted, something that also the politicians and decision makers favor. And for example, biofuel, that is one form of bioenergy in terms of transportation, has been strongly supported by US, EU, Brazil and other countries. And as a result, the global biofuels production over doubled between 2006 and 2010. So major increase there. And but then on the other hand, from these policies, there are some implications. A master's thesis of our student Hanna Melko showed back in 2008 that the EU's targets for biofuel will increase water and land use considerably, and that actually in many EU countries it would not be possible to produce that biofuel internally in those countries, but that in a way we are outsourcing part of our biofuel production, as has also happened. So with the bioenergy boom, if you wish, there is an increasing amount of non-food agriculture emerging, while, as we heard from my previous slides, there is also need for increasing amount of food being produced through agriculture. So in a way there is an equation that sounds not so simple. We need more biofuels, more bioenergy, we need more food, and the land area more or less stays constant. The amount of water available for that agriculture stays constant. So in a way the question then is that whether it's less for everyone and what to do with the question. Well, luckily there has been already some policy responses. So for example, EU is now planning a cap for their share of food crop-based biofuels after realizing the impacts on food security and on water resources. So it's the take-home message from this process, perhaps first of all, that it's good to be responsive and note that good intentions on one sector, which in this case was the bioenergy and renewable energy, can actually result in negative consequences in another sector, like food security and availability of water. Of course, one would wish that this kind of responses would be unnecessarily, and those negative consequences would be taken into account already before making such policy decisions, but it's better late than never. And this is a process that is still ongoing and under debate, but obviously a very important one also from water perspective. Let's now move to hydropower. So first to note that hydropower is produced at very different scales. There is a large-scale hydropower, which is normally over 100 megawatts, or then hydropower dams being over 50 meters in height, for example, to micro hydropower and even pico hydropower under 5 kilowatts. So there is a very large variety of different kind of hydropower production units and dams. But yet the large hydropower dams have the biggest electricity generation potential, but also the biggest negative impacts. And this is also where the discussion quite often evolves when we are talking about hydropower and its impact to water resources and related other sectors. So on the right-hand side we can see a map from the Mekong River basin in Southeast Asia. Mekong is a transboundary river, which means that it's shared by several different countries, including 6 countries in this case: China, Myanmar, Vietnam, Laos, Thailand, and Cambodia. And our research group has done over a decade work on Mekong hydropower, also working closely with the ministries and universities and organizations in the region. And so I'm going to give you a snapshot on where the Mekong hydropower development currently is. So the map shows on red the existing large hydropower plants in the Mekong, including both the Mekong mainstream and the tributaries, meaning the rivers that are flowing to the mainstream and then ultimately to the South China Sea. And with the orange color we can see all the planned large-scale dams in the basin. And as you can see, there are plenty of those. There is actually more than 100 large-scale hydropower plants being planned in the Mekong, meaning that the Mekong is seeing one of the fastest hydropower development in the world in a river basin shared by several countries. And as you can see, the hydropower is also developed quite differently. So majority of it actually being in Laos and Vietnam and less in Thailand and Cambodia, and then also upstream in China. And there are of course reasons for such development. The hydropower brings major benefits. It provides obviously electricity, but it's also a means to bring investments to the countries and also to provide income, because for example for Laos, which has called itself as a battery of Southeast Asia, the hydropower actually is also an export thing. So they export their hydropower electricity to their neighboring countries and get an income back from that resource. So it brings benefits to the countries. When we look at impacts then, and from the water perspective, so the most important impact often looked at is the flow changes. So the Mekong is a typical monsoon river, meaning that during the rainy season the water levels in the river are much higher than during the dry season. This also means that there are floodplains especially in Cambodia and Vietnam that are flooded every year during the rainy season, and that's a kind of a positive flood that brings loads of benefits both to agriculture and fisheries. But the idea of these hydropower dams is of course to level out those changes so that it's possible to produce hydropower throughout the year. And those flow changes will then have an impact on water-related ecosystems such as fisheries. They will also impact agriculture. Then there is a sediment trapping issue. So water includes sediment that is often very fertile, nutrient rich, and is important both again for agriculture and for fisheries. And the dams trap the sediment, so there is less sediment in water after dams are being built. And then dams also block the fish migration, which in the case of Mekong is a really important part of Mekong fisheries. And the Mekong fisheries is a really crucial contributor for livelihoods and food security in the countries, and their value is estimated to be between 2 to 4 billion US dollars. So it's a major thing here, the fisheries. So from here we can conclude that there are major negative impacts emerging from Mekong hydropower, particularly to immense fish production, partly also to the agriculture. And this means impacts to both livelihoods and food security. And the challenge here is that the benefits from hydropower, the electricity being produced, the income being generated, goes to different places than those negative impacts that the hydropower is causing. It goes to different groups of people, whether it's urban versus rural, or urban rich versus poor, but it also goes to different countries. So those countries producing hydropower obviously get the benefits, whereas actually the impacts are felt downstream, especially in Cambodia and its unique Tonle Sap lake. So this shows, of course, that the hydropower is a politically very sensitive issue and explains largely why there is such big debates and discussion about whether large-scale hydropower should be built, being a renewable energy source, but at the same time causing major impacts to water systems and related sectors. Okay, to conclude my presentation, I promise to provide you some solutions. The picture I have painted has been a bit gloom, but I do think that there is a possible way forward to improve the situation. There is, unfortunately, perhaps no silver bullet, so there is no one single answer how to really address this, but it's a rather a combination of many things at different scales. I have looked in my presentation global scale, so let's start from there. So globally there are some clear kind of solutions or recommendations to be made. First of all, it's clear that our food production patterns need to be changed. This is because the food production is so intense water user. So in a way we should move to produce food in areas that have enough water for that. We should consider our diets, whether it's a vegetarian diet or meat-based diet or dairy-based diet, and their kind of water consumption. And then we should also reduce food losses. And these all are areas where our researchers at Aalto University are also working on. When thinking of energy production, so one thing clearly is that we need to consider water already when planning energy production, be it the renewable energy or other sources of production. Then there is this water quality and environmental quality issue. So we should address water pollution, environmental degradation much more clearly than what we have done now, especially from industrial uses, but also from food production. And climate change is also obviously a very important part of equation, also because most of the impacts from climate change to people are coming through the changes in hydrological cycle and therefore changes in global water resources. And ultimately, of course, we should move towards better water use and management, including technical solutions, but also very much institutional and political solutions and aspects, and especially to address more clearly the different needs of different water users. So this is obviously a rather abstract level thing and something to be discussed at the UN with the Sustainable Development Goals and other targets and objectives. Locally, there is also something that we can do. First of all, to be aware of your own water footprint, which means the amount of water you are using, or your country, for example, is using through kind of food, but also consumption. And there are ways to reduce it, to use locally produced food, use foods produced in kind of water-rich areas, and so forth. So being aware of that and finding ways to reduce it, there is already one step forward. Related to consumption, of course, there is the principle of 3 R's of reduce, reuse, and recycle, which also helps to save water. More generally, of course, I really strongly recommend you to learn more about these things, to read, to write, and to think about these things and their interconnections. They are not always easy, but there's loads of material and research available online already on these topics. And of course, to be active, challenge your leaders to make sustainable decisions that also take into account water issues. So to wrap up, I could emphasize that ultimately we really talk about sustainable development and how water links to sustainable development. So when looking at, for example, sustainable development goals, it's clear that water is a cross-cutter that crosses almost all those goals and targets. And at the same time, water is both enabling factor and limiting factor for growth and development, meaning that it enables, but often and increasingly so, start to limit the growth and development because there is simply not enough water available to ensure that growth that is envisioned. And this obviously means that there needs to be some changes to be made and some decisions to be considered related to sustainable use of water. This means that we should really start to do integrated planning and policies across the different sectors, whether we are talking about water, energy, food, environment, other sectors. There are already initiatives like integrated water resources management or water, energy, food nexus that try to address these issues. They have loads of good thinking, loads of good principles, and there are loads of promising examples on how such integrated planning and policies can take place. But it's by no means easy. It's much easier to say that this is something we need to do, but it's very difficult to do. And ultimately, it really requires a political will to do so. So this has been my take on water at a rather global level and its linkages to food and energy. There is loads of information that I was referring to, and you can here find a list of it. And it also includes publications from our other university researchers that we have been involved in that has much more information, and I really recommend you to look at those as well. But with this information, you can find more ideas and views on this very interesting but somewhat challenging topic. Thank you for your attention.